Hello students, welcome back to maths class. So today I am going to continue the lesson trigonometric functions. So today we will see the sign of trigonometric functions in different quadrants, the quadrant system. Okay, so let's first of all draw the coordinate axis, that is x-axis and y-axis. This x-axis and y-axis divides this plane into four parts. So here each part is called a quadrant. So if we move anti-clockwise, then this is the first quadrant and this one is the second quadrant and this is the third quadrant. This one is the fourth quadrant. Once again, this coordinate axis divides the plane into four parts. Here each part is called a quadrant. So let us denote this is first quadrant, second quadrant, then third quadrant, fourth quadrant. Now in the previous class, I told you if we consider a unit circle means of radius 1 unit, then the coordinates of any point on this circle can be represented by the cosine of the angle theta. This is the angle theta. It is angle AOP. That is, here P is a point on this circle. Now the coordinates of the point P is A, B. So I told you this A is the cosine of angle theta and B is equals to sine of angle theta. So this coordinate of P can be represented as cos theta, sine theta. Okay. So if this point is in the first quadrant, you look at this. This is the first quadrant. So here this point P is in the first quadrant. So we know that in first quadrants the coordinates of the point P, both the coordinates of the point P are positive. So here A is cos theta and B is equals to sine theta. So A is positive, B is also positive. That means in the first quadrant cos theta is positive, sine theta is also positive. So cos, that is positive, and sine is also positive. Now what about tan theta? If cos theta is positive, then sine theta is also positive there. So tan theta, we know that tan theta is sine upon cos. So that is also positive. Then sec theta. Sec theta is the reciprocal of cos theta. So that is also positive. Now cosec theta. Cosec theta is the reciprocal of sine theta, that is also positive. And cot theta, what about cot theta? Cot theta can be written as cos theta by sine theta, or it can also be written as the reciprocal of tan theta. So that is also positive. So in the first quadrant, here the point P lies in the first quadrant and this point, the coordinates of the point P is A, B. Both the coordinates are positive there. That means cos theta is positive, sine theta is positive. So all the trigonometric functions in the first quadrant is positive. We are discussing the sign of trigonometric functions in different quadrants. So in the first quadrants, all trigonometric ratios, all trigonometric functions are positive. So we will write here all positive. In the first quadrant, all trigonometric functions are positive. Now, if we take this point P, A, B, if we take the point P, A, B in the second quadrant on this circle. Now, in the second quadrant, we know that the coordinates of the point P is here the negative side of x-axis it is. So, we will take the coordinates as minus A, B. Okay, y coordinate is B and x coordinate is minus A. Now, again this x coordinate can be represented as cos of theta. So, this is the angle theta now. Okay, this is the angle theta. Here theta is greater than pi by 2, less than pi. Theta is greater than 90 degree and less than 180 degree. So in this way we will get this is sine theta. So if the coordinates of the point P is represented by cos theta and sin theta. So we will get cos theta is negative there and sin theta is positive. So in the second quadrant, we will get sin theta is positive. Sin is positive because the y coordinate is positive there and x coordinate is negative, and cos theta is negative. Okay. So what about tan theta? Tan theta is sin theta by cos theta. So tan theta is, it is plus divided by minus, so it is negative. And the reciprocal of sin theta, that is cosec theta. Cosec theta is positive. Okay. Now sec theta, what is sec theta? Sec theta is the reciprocal of cos theta, so it is also negative. And cot theta, that is also negative. So in the second quadrant means here this angle is pi by 2, this is pi and this is 3 pi by 2. Now this angle is 3 pi by 2 and this one is the total angle, that is 2 pi. We can write 2 pi, it starts from 0 radian or 0 degree. Okay. So in the first quadrant 0 to pi by 2, all trigonometric functions are positive. And in the second quadrant, you look at this is sine positive and the reciprocal of sine, that is cosec, is positive. So we will write here sine positive in the second quadrant. That means when theta is greater than pi by 2 and less than pi. Theta is greater than 90 degree and less than 180 degree. Sine is positive. Obviously, the reciprocal of sine is also positive. That is cosec is also positive. The trigonometric function sine, it is the full form of sine, that is sine. Okay, sine is positive and cosec is also positive. But all other trigonometric functions are negative there. Okay. Now, if we take this point P in the third quadrant. Third quadrant means where theta is greater than pi and less than 3 pi by 2. If we take the point P here now the coordinates of P is minus a comma minus b. Here both the coordinates, x coordinate and y coordinate, both are negative. So this is the angle theta now. Here theta is greater than pi. Here it is the angle pi and it is 3 pi by 2. So theta is greater than pi and less than 3 pi by 2. So theta lies in the third quadrant. Okay. This point also lies in the third quadrant. So in third quadrant, both the coordinates are negative. That means cos theta, x coordinate is represented by cos theta and y coordinate is represented by sin theta. So cos theta is negative, sin theta is negative. And what about tan theta? Tan theta is, we know that tan theta is sin by cos. So minus divided by minus, that is plus. So tan theta is positive. Okay. Now the reciprocals, cos theta is negative. So sec theta is also negative. Then sin theta is negative. Cosec theta is negative. And tan theta is positive. So the reciprocal of tan theta, that is cot theta, is positive. Okay. So in the third quadrant means theta is greater than pi, less than 3 pi by 2. Theta is greater than 180 degree and less than 270 degree. So there only tan theta is positive and the reciprocal of tan, that is cot theta, is positive. So in the third quadrant, we will write tan is positive, tan positive, and the reciprocal, that is cot, is also positive. So we will write here capital T. So tan positive and cot positive. Now let's move on to the fourth quadrant. So if this point P is taken as a point in the fourth quadrant, this point P is at the fourth quadrant on the circle. Now here x coordinate will be positive, whereas y coordinate will be negative. Okay. So the coordinates of the point P is A comma minus B. Now the angle theta is greater than, this is the angle theta now, it is greater than 3 pi by 2 and less than 2 pi, less than 2 pi. If we complete one revolution, the angle will be 2 pi. So this angle theta is greater than 3 pi by 2, less than 2 pi. So in this fourth quadrant here, x coordinate is positive and the y coordinate is negative. So cos theta, in the fourth quadrant, x coordinate is positive, means cos theta is positive and sin theta will be negative. Sin theta is negative. So what about tan theta? Tan theta is sin upon cos. So it is also negative. And the reciprocal of cos, that is sec theta, that is positive. As cos theta is positive, so sec theta is also positive. And what about cosec theta? Reciprocal of sin theta, that is negative. And tan theta is negative, so cot theta is also negative. So look at this, in the fourth quadrant, cos theta is positive and this sec theta is also positive. So we'll write in the fourth quadrant, cos is positive, cos is positive, and the reciprocal of cos, that is sec, is positive. Okay. So in the first quadrant, all the trigonometric functions are positive. First quadrant means if theta lies between 0 to pi by 2, theta is greater than 0 and less than pi by 2. In the second quadrant, sin is positive and cosec is also positive, as cosec is the reciprocal of sin. So here theta lies between pi by 2 to pi, that is theta is greater than pi by 2 and less than pi. And in the third quadrant, theta is greater than pi, less than 3 pi by 2. Here tan is positive and cot is also positive. And in the fourth quadrant, theta is greater than 3 pi by 2, less than 2 pi. So in the fourth quadrant, cos is positive and sec is also positive, as sec is the reciprocal of cos, and all the other trigonometric functions are negative there. So how to remember this formula? Okay, how to remember what is the sign of trigonometric functions in different quadrants? Just you take the first letters of all these, that is all positive. I am taking A there, all positive. In the first quadrant, all positive. In the second quadrant, sin positive. Take S from there, sin positive means cosec is also positive there, but the main function is sin. And in the third quadrant, tan positive. T, take the first letter T. And in the fourth quadrant, cos is positive, so take the first letter C. Now you have to remember this acronym only, ASTC. This is the shortcut to remember all these concepts of sign of trigonometric functions in different quadrants, that is ASTC. All positive, sin positive, tan positive, cos positive. This is cos, not cot. Okay, ASTC, as the main functions here are sin, tan and cos, and all the other trigonometric functions are reciprocals of this. So you have to remember ASTC. Now how to remember this ASTC? Just I am telling one trick to you to remember this ASTC. This is a quadrant system and the nature of sign of these trigonometric functions. So ASTC, let's make a full form to remember this. Okay, so add sugar to coffee. Just to remember this, you remember this one, ASTC, and this is add sugar to coffee. Just to remember this one, add sugar to coffee. Add, you take the first letter A, all positive in first quadrant, and S for sugar, that means sin positive in the second quadrant, and T, tan positive in the third quadrant, and C, it is cos positive in the fourth quadrant. So where cos is positive, sec is also positive, where tan is positive, cot is also positive, where sin is positive, cosec is also positive. So just you have to remember this ASTC. Once again I am telling, A all positive, S sine positive, T tan positive, and C cos positive. So you remember this one. This is the trick to remember ASTC, add sugar to coffee. Okay, I hope you understood this one. Clear? Now let's move on to the next topic of this lesson, that is domain and range of trigonometric functions. As I told you, these trigonometric ratios are considered as trigonometric functions. So we have to discuss about the domain and range of these trigonometric functions. So first trigonometric function is fx is equals to sin x, or we can also write it as y. Fx is equals to sin x. Now what about the domain of this function? Here domain means all the permissible values of x for which this function is defined. So here we know that we can find the value of sine for every real number. So here the domain of this function is set of real numbers. And what about the range of this function? Now I told you this sin x represents the y coordinate of a point P on the unit circle. Okay, unit circle means it is of radius 1 unit, that I already told you. This B is equals to sin x. So, and the coordinates of this point, this is 1 unit, so the coordinates of this point is 1, 0, this is 0, 1, and this is minus 1, 0, and this is 0, minus 1. So look at this figure, this is B. B represents the sine of angle x. Now this angle is x actually. So what is the maximum value of B here? This length is now B. Here 1. The maximum length of this B is equals to 1. And what is the minimum length of B? So B, the minimum length is minus 1. That means if B is equals to 1, it is the maximum value of sin x, and if B is equals to minus 1, then it is the minimum value of sin x. So the range of sine function is closed interval minus 1, 1. That means the images for the x belongs to R. The images of sine of x, the value of sine x is greater than equals to minus 1 and less than equals to 1. So the domain of sine function is set of real numbers, and the range of sine function is closed interval minus 1, 1. Now let's come to the second function, that is cos function. So if it is fx is equals to cos x or y is equals to cos x. Now this coordinate A, x coordinate is A here. So A represents cos of angle x. So it can be represented as cos x. So what is the maximum value of cos x here? It is on the x-axis, you see, it is 1. This length is 1 unit. So it is the value of A here, and it is the value of A here. So the maximum value of A is 1 and the minimum value of A is minus 1. So again, domain of this function is set of real numbers, and the range is closed interval minus 1, 1, as the maximum value of cos x is 1 and the minimum value of cos x is minus 1, as A is less than equals to 1 and greater than equals to minus 1. So A represents nothing but cos x. Okay. So it is the domain of cos x is set of real numbers, and the range of cos x is closed interval minus 1, 1. Now let's come to the next function, that is cosec x. If the function is fx is equals to cosec x, we can also write it as y. Y is equals to fx is equals to cosec x. Now we know that cosec x is equals to 1 upon sin x. Cosec x is the reciprocal of sin x. So cosec x is not defined whenever this sin x is equals to 0. So we know that sin x is equals to 0 implies x is equals to n pi. So for all integral multiple of pi, this sin x is not equals to 0. So for the domain of this function, domain means whenever this function is defined for the values of x, for what values of x this function is defined, all that values of x will be under this domain. Okay, so the domain of this function here, sin x is equal to 0 if x is equal to n pi. So for the domain of this function, x should not be equals to n pi, because if x is equals to n pi, then this sin x will be 0 and cosec x will be not defined. So the domain of the cosec function, set of real numbers minus, it is n pi, where n belongs to z. At all integral multiples of pi, this sin x becomes 0 and under this cos x become not defined. So we have to subtract this all n pi from the set of real numbers domain. Now let's come to the range of this cosec function. Now what is cosec x? Again, cosec x is 1 by sin x. We know that the range of sine function, what is the range of sine function? That is closed interval minus 1 comma 1. So sin x is greater than equals to minus 1 and less than equals to 1. Now cosec x is the reciprocal of sine function. If sin x is greater than equals to minus 1 and less than equals to 1, so what about 1 by sin x? 1 by sin x. So 1 by sin x will be greater than equals to 1 and less than equals to minus 1. Okay, 1 by sin x. Just take one example here. If the value of sin x is 1 by 2, if the value of sin x is 1 by 2, it is less than 1. So the range of sin x is closed interval minus 1 comma 1. So the value of sin x may be 1 by 2. Now what is the reciprocal of 1 by 2? That is 2. So 2 is greater than 1. That means if we take the reciprocal of cosec x, that is 1 by sin x, 1 by sin x is greater than equal to 1 or less than equal to minus 1. So the range of cosec x, range of cosec x is equals to, this is minus infinity comma 1 union 1 comma infinity. Actually here this interval, in this interval it is less than equals to 1 and greater than equals to, it is less than equals to minus 1 and greater than equals to 1. Okay, so the range of cosec x is, just you see on the number line, it is minus 1, it is 1. So all the real numbers which is greater than equals to 1 and less than equals to minus 1 will be under the range of this cosec function, and there will be no image in between minus 1 and 1. Clear? So this is the range of cosec function. That means all real numbers greater than equal to 1 or all real numbers less than equals to minus 1. Okay. Now let's come to the range and domain of this sec function. Again, sec x. We know that sec x is the reciprocal of cos x. So cos x will be 0 if x is equals to 2n plus 1 pi by 2. That I told you in the previous class. So cos x is equals to 0 if x is equals to odd multiple of pi by 2. So for sec x to be defined, this x should not be equals to 2n plus 1 pi by 2. So the domain of sec x is set of real numbers minus 2n plus 1 pi by 2, where n belongs to z. So we have to subtract the all odd multiples of pi by 2 from the set of real numbers. Now again, range is as same as cosec x, because this sec x is the reciprocal of cos x. So we know that the range of cos x is closed interval minus 1 comma 1. So for the range of sec x, we will not get any image between minus 1 and 1, whereas we will get image greater than equals to 1 and less than equals to minus 1. So we will write is equals to the interval minus infinity comma minus 1, it is closed here, minus 1 is included, union 1 comma infinity plus infinity. That means all the images for sec function is greater than equals to 1 or less than equals to minus 1. Clear? Now let's take the next function, that is fx is equals to tan x. Fx is equals to tan x, or we can also say that y is equals to tan x. Now what about tan x? We know that tan x is equals to sin x divided by cos x. So this function is defined only when cos x is not equal to 0. So when cos x is equals to 0, we know that x is equals to, again it is 2n plus 1 pi by 2. So where n belongs to z. So whenever x is equals to 2n plus 1 pi by 2, then tan x is not defined. We know that tan pi by 2 is not defined, tan 3 pi by 2 is not defined. So we have to subtract this all odd multiples of pi by 2 from the set of real numbers to get the domain of this function. So the domain of tan x is set of real numbers minus 2n plus 1 pi by 2 where n belongs to z. Clear? Because here the denominator is cos x, so the denominator should not be equals to 0, and we know that cos x is equal to 0 gives us x is equals to 2n plus 1 pi by 2. So whenever x is equals to 2n plus 1 pi by 2, that means odd multiple of pi by 2, tan x will not be defined. So we have to subtract all odd multiples of pi by 2 from this set of real numbers to get the domain of this function. Now what about the range of tan x? Range. Now we know that if we take pi by 2, 3 pi by 2 or minus pi by 2, minus 3 pi by 2, then tan x will be not defined, or we say that infinity. So in this case we can say that the range of this tan x is the open interval minus infinity comma infinity. That is nothing but the set of real numbers. Set of real numbers. Okay. So the domain of tan x is set of real numbers minus 2n plus 1 pi by 2 where n belongs to z, and the range of tan x is set of real numbers. Okay. Now let's move on to the next function, the last function, that is cot x. If fx is equals to cot x, now we know that cot x is equals to cos x divided by sin x. Here the denominator is sin x. So to be defined, cot x to be defined, sin x should not be equals to 0. So we know that when sin x is equals to 0, x is equals to n pi where n belongs to z. That means for all integral multiples of pi, sin x will be 0. So if sin x will be 0, then cot x is not defined. So we have to subtract this n pi, all integral multiples of pi, from the set of real numbers. It is defined for all real numbers but not for x is equals to n pi. So the domain of this function is, domain of cot x is equals to set of real numbers minus n pi, means x is equals to n pi is subtracted from set of real numbers. So it is n belongs to z. So what about the range? Again range is, here also for integral multiples of pi, this cot x is not defined. That means it will goes up to infinity or and minus infinity. So the range of this function is minus infinity comma infinity, open interval minus infinity comma infinity. It is nothing but set of real numbers. Okay. So here is the domain of sine function, that is set of real numbers, and the range of sine function is closed interval minus 1 comma 1. That means all the images of this sine function belongs to this closed interval minus 1 comma 1, and the domain of cos function is set of real numbers. Similarly the range is closed interval minus 1 comma 1, and the domain of cosec function set of real numbers minus n pi, and the range is the interval minus infinity comma minus 1 union 1 comma infinity, means it is all real numbers greater than equals to 1 and less than equals to minus 1. Okay. and the domain of sec x is set of real numbers minus 2n plus 1 pi by 2, and the range is minus infinity comma minus 1 union 1 comma infinity. Similarly, the domain of tan x is set of real numbers minus 2n plus 1 pi by 2, where n belongs to z, and the range is set of real numbers. And the domain of cot x, that is set of real numbers minus n pi. Okay, this at n pi, this cot x is not defined, so it is the domain is set of real numbers minus n pi, and the range is set of real numbers. So that's all for today, students. I hope you understood all the concepts that we discussed today about the sign of trigonometric functions in different quadrants and the domain and range of trigonometric functions. Okay, so let's meet in the next session. Till then, bye bye. Thank you very much.